Okay, here we've got a similar question to the previous one, except that we've got an inclined plane. Remember, with an inclined plane, the easiest thing to do is to tilt your reference axes. Okay, so let's read this. A body of mass 4 kilogram rests on a plane inclined at an angle of 30 degrees to the horizontal. It is just prevented from moving by friction. Calculate the coefficient of friction. Okay, so let's draw our plane in. Okay, there we go. It's just like I wrote from the previous example. And here is our object at rest on that plane. Now remember, our weight force always acts directly down, and our normal force always acts at 90 degrees to our plane, and friction is preventing it from moving. Now, a ball or a body will roll down a hill, so the friction must be acting in this direction to prevent it from moving. And we are going to say that we have tilted our axes to make our calculations easier. Now, our plane is angled at 30 degrees to the horizontal, and so our angle that our weight force makes to our new J plane is also going to be 30 degrees. All right, I've got my diagram going here. I'm going to define all my variables first. So we're going to let R be the resultant vector, or resultant force, sorry, measured in newtons. We're going to let F be the friction force, measured in newtons. W will be the weight force measured in newtons, and N will be the normal force also measured in newtons. Now this thing is not moving, so therefore the forces are in equilibrium. Object is not moving, therefore in equilibrium, and that means that R is equal to 0, which is an important thing. Okay, let's write down all our forces. So we know, we've said that R is 0I plus 0J. Our frictional force is easy to do because it is just in the positive I direction. Notice with my twisted axes, so it's just going to be Fi. My normal force is in the positive J direction, so it'll just be Nj, and my W is going to be, well, now I need to find my components. So I've got a sine ratio for my I component and a cos ratio for my J component. So and negative I and negative J. So I'm going to have negative W sine of 30 degrees I minus W cos of 30 degrees J. Now remember that W is mass times gravity, so that's 4 times 9.8. So we're going to have negative 4 times 9.8 sine of 30i minus 4 times 9.8 cos of 30 degrees J, and that 4 times 9.8 was 39.2, I think. Yeah, it was 39.2. So negative 39.2 sine of 30 degrees I minus 39.2 cos of 30 degrees J. All right, now we can put them all together. We've got all of our forces. We know that R is F plus N plus W, and that's just going to be Fi plus Nj minus 39.2 sine of 30 minus 39.2 cos of 30. And our R was 0I plus 0j. Once I've got that, I can equate my I and j components. So that I've got 0 is equal to F minus 39.2 sine of 30, and 0 is equal to N minus 39.2 cos of 30. So F is going to be 19.6 newtons, and N is going to be 33.95 newtons. I haven't answered my question yet because they want my coefficient of friction mu, but I know that F equals mu N, so 19.6 is mu times 33.95, and mu is 0.577.